All right, one last look here. We're just going to do a quick look at an analog waveform just so you kind of get the gist and can kind of see it as it's happening. All right, all I really did is I took that first circuit we had and I replaced it with a sinusoidal voltage, and I made that the peak voltage on that 2 volts, operating at 60 hertz so we can see it. And we're going to take a look. So I'm going to go ahead and simulate it here. I'm going to open up the oscilloscope and we can see that waveform being created. Okay, so nice perfect sine wave going on here. Notice the scale. Okay, on the Y scale it's 1 volt per division. So each one of these boxes is 1 volt high. Alright, so it's very important that we understand that. So I'm going to pause it from working right now. So I'm going to pause the signal. Let's analyze it and let's look at the circuit at the same time. Alright, so I said that the peak voltage is 2 volts. So if I go from this center line to the crest or the top of the wave, that's 2 volts right here. Alright, remember we talked about the amplitude. So we have the peak voltage or the amplitude, which is 2 volts, and then we have the peak to peak voltage, which is from the top, the crest of the wave, to the base of the wave or the trough of the wave. Alright, so if this is 2 volts, this is 2 volts right here. So the total peak to peak voltage is 4 volts. Alright, I can also analyze the period just like I did in the other ones. Alright, and I try to get it in a nice, let's get a nice spot right there. So we use that one, and then we take a look at right there. Alright, so the period is about 16.78 milliseconds. So T1 minus T2, I'm getting that from right here because this blue one you can't see real well on the screen probably. That's T2, this is T1 for our time markers. Now if I wanted to stretch this out a little bit, I can change my X scale, alright, and make it scrunched down, or say I need to see it a little bit better, really need to analyze what's going on in that signal. Alright, I can stretch it out a little bit and do that. I can do, remember, the same thing with the voltage per division here, and I can make it so I can't even see it. So sometimes when you start graphing these, you may not see the signal right away. You got to play with your settings here on your X and Y scales. Not necessarily your X and Y position, remember that shifts the graph up and down, but the scales at which you're taking a look at this. Alright, once again, you can still reverse this if you want to, just like the others, but I wanted to show you an analog signal as opposed to the first two I showed you were a digital signal. So this might be something that looks, you know, how your voltage is coming in. In fact, maybe we can do that real quick. So I'm going to stop this, alright, and then let's come over here. I'm going to close the oscilloscope for a second. Alright, so let's say your peak voltage, your 110, 120 volts right there out of your house. So I can double click on that, change it to 120 volts at 60 hertz. So this is really what your electricity is going to look like when you plug in to your wall. Alright, 120 volts, 60 hertz, okay, single phase. I'm going to hit play. I'm going to open the oscilloscope. I can't even see it, right? Well, that's because of this issue right here. So we need to really make that so that we can see it. 100 volts per division. There's 50 volts per division, which means, alright, if I pause this here, this is 50 volts, this is 100 volts, right? And we know that this is 20 because I set it at 120. So the electricity in your house, this is pretty much essentially the signal. I just have a sine source here and it's 120 volts. So this is essentially how your electricity is getting transmitted. So when you plug in your phone, when you plug in your vacuum, when you plug in your coffee pot, when you plug in anything in your house, alright, this is single phase, and this is what your electricity is doing at your house when it's pushing the electrons through to operate all your motors and everything else, your TV, your lights, all that. So that's what your basic electrical signal is going to look like there. And this is it for analyzing signals, analog and digital. You'll get to do that again in class. We'll have some assignments on it. It will be on your quizzes and tests as well. You will have your lecture quizzes to do this on and your other assignments. So remember, any questions, go ahead and email me, or we can talk in class and go over some things that you might have questions about understanding and how to analyze the signals and maybe how to use multisim.